Hello students, today we are going to start our module number 3 and lecture number 1. Okay, the name of our module 3 is Reaction Dynamics, Nuclear Reactors and Accelerators. In this first we are going to study reaction dynamics, after that nuclear reactor, and third is accelerator. Actually, what is the correlation in 3? See here, when there is any reaction is carried out in a nuclear reaction, to carry out that nuclear reaction, we should have the experimental control or experimental setup. Okay, and that experimental setup is called nuclear reactors. And to start that nuclear reaction, we should have high energy particle to accelerate that reaction, and that is our third topic, accelerators. Okay, now see here just introduction. In nuclear physics, many more nuclear reactions are important, such as nuclear fission reaction, nuclear fusion reaction, scattering reaction. In order to study nuclear phenomenon, we must able to understand this nuclear reaction. Okay, means there are many nuclear reactions such as fission reaction, fusion reaction, scattering reaction. In order to study all these phenomenon, we should have to study the nuclear reaction. First part of this module belongs to the different types of nuclear reaction and their reaction mechanism. These nuclear reactions are carried out in controlled environment, as I discussed in previous slide. These nuclear reactions are carried out in controlled environment. Device which is used for this purpose is named as nuclear reactor. Okay, means the nuclear reaction is carried out in that controlled environment is known as nuclear reactor. And the second part of this module is dedicated to our that nuclear reactors. In addition to nuclear reactor, to stimulate nuclear reaction, we require the energetic particles. In order to accelerate charged particle, certain devices are designed, and these devices are known as accelerators. These accelerators are studied in our third part of this module. Understand means in this module we are going to study nuclear reaction, after that reactors, and after that accelerators. Now first one, reaction dynamics. See here, nuclear reaction are carried out through different ways, means there are different types of nuclear reaction given as follows. Okay, there are different type of nuclear reaction. In all, there are 10 categories of nuclear reaction. The first one is elastic scattering. As we know, elastic scattering means there is no energy loss. See here, in this reaction, the incident particles strike the target nucleus and leaves without energy loss, but in general with altered direction of motion. That is, in that elastic scattering, there is a only change in direction, there is a no change in energies. Okay, see here, scattering of alpha particle in gold is a good example of this process, and this example is given here. See here, that is our alpha particle, that is our gold nucleus. Okay, and that's reaction, you can see just direction is changes. Okay, there is no energy loss. Next one is inelastic scattering. The scattered particle may lose kinetic energy, this being corresponding increase in the internal energy of the nucleus, which is goes to the excited state, that is to the high quantum state. This inelastic scattering can be represented as follows here. This 7 lithium 3 star, this is a excited state of that lithium. That is, in elastic scattering, there is a loss of kinetic energy of that incident particle, and that energy is carried out by that nucleus. Okay, and that nucleus energy is increased, and that's why that nucleus goes to its excited state, and here excited state is denoted as 7 lithium star. Okay, now next one, disintegration. On striking the target nucleus, the incident particle is absorbed and different particles is ejected. The product nucleus differs from the target nucleus. As see here our target is nitrogen, okay, but when there is a alpha particle incident on that nitrogen, there is a emission of a oxygen plus hydrogen, means the target is nitrogen and the product is oxygen, means in the disintegration process product nucleus is differ from that target nucleus. Okay, now next one is photo disintegration. The gamma rays are absorbed by the target nucleus, exciting it to the higher quantum state. If the energy is high enough, one or more particles may be liberated. See here, what is actually photo disintegration then? When gamma ray is incident on the target nucleus. Here gamma ray is incident on that hydrogen nucleus. Then what is happening? That hydrogen nucleus is goes to its higher quantum state and it emits the or it liberates the neutron. Okay, next one, radiative capturing. See here, the particle may combine with the nucleus to produce a new nucleus or compound nucleus which is in excited state. The excess energy is emitted in the form of gamma ray photons. This type of process is known as radiative capturing process. Means what? See here 12 magnesium, okay, and that is our target and that is our projectile. When hydrogen is incident on this magnesium, then there is a formation of compound nucleus and that compound nucleus is in excited state. When that compound nucleus came to its ground state, it emits the gamma photon. Okay, means in radiative capture process there is a formation of compound nucleus. See here, direct reactions. A collision of an incident particle with the nucleus may immediately pull one of the nucleons out of the target nucleus by the so-called pickup reaction. In the inverse process, bombarding particle composed of more than one nucleon may lose one of them to a target by the stripping reaction. See here, this is very important topic. A collision of an incident particle with the nucleus may immediately pull one of the nucleons. See here, this is our projectile, okay, or incident particle, and this is our nucleus. When there is incident particle is collide with this nucleus, there is a immediately pull one of the nucleons out of the target, and by the so-called pickup reaction, in inverse bombarding particle composed of more than one nucleon may lose one of them to a target by stripping reactions here, and this is deuteron, okay, and when this deuteron is incident on that our target nucleus which is copper, then there is a formation of copper 64, that is isotope with emission of a hydrogen. Okay, that's why it is called an stripping reaction. Now what is spontaneous decay? Beta and alpha decay processes may be regarded as this type of nuclear reaction. Means spontaneously decay is observed in that beta and alpha decay, that is there is no experimental control without any external energy given. Spallation reactions. On capture of incident particle, a heavy nucleus has sufficient energy for this ejection of several particles. Such a reaction is known as spallation reaction. See here, when there is a heavy nucleus, an incident particle is incident or the target particle, when that target particle is incident on that heavy nucleus, which is having the sufficient energy for this ejection of several particles, means when there is a target, when there is a projectile is incident on the target nucleus and that projectiles have a sufficient energy, then there is a ejection of a several particles from that heavy nucleus. Here this is our uranium and this is our neutron. Then there is a emission of a zirconium and Ta and plus two neutron also. Okay, means there is a several particles are emitted. Now next one is high energy reaction. In the energy range about 150 and spallation process merge it into new kind of reaction in which new kinds of particles like meson are produced along with proton and neutron. Means in that high reaction up to the high energy reaction we studied that when there is emission of particle there is either neutron, hydrogen, okay, that is emitted. But when there is a high energy reaction means when there is a projectile which is incident on the target nucleus have high energy, then there is a maybe emission of a meson's particle. So meson is an antiparticle. Next one is heavy ion reaction. This nuclear reaction induced by heavy ions also include conventional reactions mechanism such as Coulomb excitation, elastic scattering, compound nucleus formation and direct reaction. Means heavy ions reaction is which is heavy ions reactions. Actually heavy ions reaction includes Coulomb excitation, elastic scattering, compound nucleus formation and direct reaction. As we studied in previous slides, there is a direct reaction, compound nucleus formation also, elastic scattering also. Means heavy ion reaction consists and these types of reaction. Examples charge particle reaction, neutron reaction, electron induced reaction. Means in today's lecture we just studied the different types of nuclear reaction. Okay, thank you.